and Friday, I told you guys the reason that we learned how to solve it in the calculator was so that you guys would understand what it was that we were finding, right? We were finding where did the graph of sine or cosine, you know that both make those wavy lines, where did it intersect some value, right? Like 1/2 or 1 or 0.25, right? Things like that, right? Where did they intersect at? That's what we were finding. And then at the end of the notes on Thursday and at the end of the assignment that we worked on Friday that we just graded, once we understood what we were looking for, that made it a little bit easier for us to find what we were looking for algebraically, okay? So that's what we're going to be doing here. We're going to be solving algebraically those equations. So my answers should be things like pi fourths or 5 pi sixths or 5 pi thirds, things like that. All right? It does tell us here that we are supposed to be solving these by using factoring and by using identities. So like our basic 8. Okay? So on number 1, it says we've got 2 sine squared of x minus 3 sine of x plus 1. Well, that's not any of our basic 8 identities, right? So that must mean we should use factoring. So remember, this is the same as if I had 2x squared minus 3x plus 1. I can factor that, so I can factor this. Remember, when I make my factors, whatever I put at the beginning of each of my factors would come from that first term, right? What would multiply to give me 2x squared? Right, in this case, yes, it's for sine, yeah, because 2x squared would be 2x and x. So 2 sine squared would be 2 sine and sine. So 2 sine of x and sine of x would multiply to give me 2 sine of x squared. All right, and then we're supposed to look at the last term to decide what to put here and here. Well, what multiplies to give me 1? Okay. Now I have to make sure that I use the right signs. So remember, this is where you check inside and outside. What is 1 times sine of x? Okay, so this would be 1 sine of x. All right, and then I'm going to check the outside. What is 2 sine of x times 1? Right. And my goal here is to get -3, right? The number in the middle is what they're supposed to add to. What would my signs need to be for this and this to give me -3 sine? Right. I need them to both be negatives, right? Okay, so those are my factors. All right, so we've done this before, and you've done it in previous classes as well. Whenever you find your factors, how do you solve a factor? Set them equal to 0, exactly. So I'm going to have 2 sine of x minus 1 equals 0. And I'm going to have my other factor, sine of x minus 1 equals 0. So I just took what was in those parentheses and set them equal to 0. And this is going to be exactly what we were doing on our notes and assignment. So I'm trying to get sine by itself here, all right, just like I would any value of x. What would I move first to get the x by itself here? Add the 1. Okay, so I add the 1, and then I've got 2 sine of x equals 1, right? Then what should we do? Divide by 2. So then I'd have sine of x equals 1/2, right? Okay. And this is where it comes into play, where we're looking for our values, right? Like pi thirds, things like that. So most of us use that hand trick to figure out our ratios, right? Okay. For sine, remember sine is number of fingers to the right over 2. All right. So the 2 is here in the bottom. This is number of fingers to the right. What finger do I bend so that I only have 1 finger to the right? Okay, and how many degrees is this? 30 degrees. And what is 30 degrees in radians? Pi over 6. Very good. So that's going to be my first answer, pi over 6. All right, now this was a positive 1/2, right? So there are two places where sign can be positive. Remember on our graph, all students take classes. Besides quadrant 1, where everything is positive, where else is sign positive? Quadrant 2, okay? So I need a multiple of pi 6 that would fall in quadrant 2. So what would be like pi 6 but in quadrant 2? Right. So that's where we need to have those memorized. So if you have forgotten, you need to go back and study. Okay? All right. So those are the solutions that we got from our first factor. Don't forget, we still need to solve this one and do the same. Okay, so how would I solve that second factor? Add 1. So I'll have sine of x equals 1. Okay, well, this is going to have to be something that's not in between, right? Because it's supposed to be over 2, if it is, right? So this must be 1 over 1. Okay, it can't be this one because this would be square root of 2 over 2. Square root of 2 over 2 is not 1, right? Square root of 2 over 2 is square root of 2 over 2. But if it was square root of 2 over square root of 2, that would be 1, but that's tangent, not sine, okay? So I'm asking myself, we know r is always 1, right? And sine is y over r. So on a coordinate plane here, where is y 1? At the top. Yeah, this is the point 0, 1. So where is that? Pi halves, yeah. So x would have to be pi halves, right? And there's nowhere else where our y value is 1. If you went down, it's negative 1, right? So that wouldn't work. Left and right, it would be 0. So that's the only solution we come up with. So if you were supposed to make me a list of the answers, typically we see them listed in order from smallest to biggest. So what would be the smallest answer we came up with? Pi 6. And then the next would be pi halves. And then our last answer would be the 5 pi 6. So if this were a multiple choice question on a test, that's what you'd be looking for. Okay, let's do another one. Okay, number 2 is 2 cosine squared plus cosine equals 0. Again, this doesn't really look like one of our basic 8, so we must need to factor it. Okay, so this time I don't have 3 pieces, I've only got 2 pieces. But in this piece and this piece, do you guys see anything that they have in common that I could factor out, like a GCF? Cosine. Okay, so let's do that. So let's factor out a cosine of theta. So if I take cosine of theta out of 2 cosine squared of theta, what's left? 2 cosine. All right, and if I take cosine out of cosine, what's left? 1. So plus 1. All right. So now it's kind of like before. I have 2 pieces, 2 factors. So all I have to do to solve a factor is take it and set it equal to 0. So I'm going to set cosine of theta equal to 0. And I'm going to set 2 cosine of theta plus 1 equal to 0. All right, so for this first one, I don't really have any solving to do, right? It's already all by itself, okay? And so for cosine of theta, for that to be 0, remember that's when we're thinking about x over r, right? Well, we know r is always what? 1, okay? So I'm really looking for where x must be 0 if it gave me 0. So where on a coordinate plane is x 0? At the top and the bottom. Okay, so where are those 2 locations? Good. So pi halves, and 3 pi halves would be the two answers we get there. All right. Now for this next one, we need to solve, right? Got to do a little solving. So what should I do first?
Subtract 1.
Subtract 1. So 2 cosine of theta equals -1. And then what should we do? Divide. So we're going to have cosine of theta is equal to -1/2. All right, so cosine, like we said, x over r, or if you're using the hand trick, is number of fingers to the left over 2, all right? Okay, so it is over 2. This is number of fingers to the left, but this is negative, right? So I'm thinking all students take classes. Where is cosine negative? Right, so I'm looking for answers here. Okay, so I'm going to ignore the negative for now. Which finger would I bend so that I have one finger to the left? Index finger, which is pi over 3, pi thirds. All right, so I need a multiple of pi thirds in those two quadrants that we said our answers would be in, right? So what's equivalent to pi thirds or a multiple of pi thirds in quadrant 2? What would it be? 2 pi thirds. Good. So I'd have 2 pi thirds. All right, and what would be a multiple of 2 pi thirds in quadrant 3? Good. Oh, sorry, not 5, but 4. All right, 4 pi thirds. All right, so we came up with 4 answers. Remember, typically we see our answers written from smallest to biggest. So what would be our smallest answer? Pi halves. All right, and what would be next?
2 pi thirds.
2 pi thirds. And then
4 pi thirds.
4 pi thirds. And then lastly, we would have
3 pi halves.
Nice. So those would be our solutions. All right. Okay, so flip it over on to the back of that page. Let's look at another one. Number 3 says we've got 2 cosine squared plus cosine equals 1. Again, not necessarily looking like one of our basic 8 identities, so I probably do want to factor it. But in order for us to factor, everything has to be on one side of the equation, right? If you look back at the ones we solved, equal to 0, right? Equal to 0. So, what do we need to do first? Right, so how am I going to fix this? Subtract 1. So I'll have 2 cosine squared of b plus cosine of b minus 1 equals 0, right? Okay. So now we should be able to factor this. So I'm going to take 2 parentheses. And remember, whatever I put at the front of my parentheses comes from my first term. So what would multiply to give me 2 cosine squared? Right. So 2 cosine of b and cosine of b. And then remember, I look at the last term to decide what I put here and here. What multiplies to give us 1? Right. Now, I just need to double check where I'm going to put signs, right? So on the inside, 1 times cosine would give us 1 cosine, right? On the outside, 2 cosine times 1 would give us 2 cosine, right? And I want it to add to give me, remember that's an understood 1 there, right? So what would our signs need to be if 1 cosine and 2 cosine adds to give me 1? Where would I put them? Yep. If this one's negative and this one's positive, then the negative goes here, the positive goes here. All right, so I found my factors. How do I solve factors? equal them to 0. Okay, so I'm going to take that first factor, which is 2 cosine of b minus 1, set it equal to 0. And then I'll take the other one, cosine of b plus 1, and set it equal to 0. All right, so how do I solve that first one? Add 1 and then divide by 2. So we'll end up with cosine of b equals 1 over 2, right? Okay, remember, cosine is number of fingers to the left, right? So which finger do I bend so that I've got 1 to the left? Okay? Which is what? Pi thirds, right? And am I looking for where it's positive or negative? Did we have positive 1/2 or negative 1/2? Positive, okay. So cosine is positive in quadrant 1, so pi thirds would be our first answer. What other quadrant is cosine positive in? 4. So what would be equivalent to pi thirds or a multiple of pi thirds in quadrant 4? We said in a second ago that in quadrant 3 it was 4 pi thirds, right? So this would be 5 pi thirds. Good. Okay? All right, for that second equation, what do I need to do to solve? Subtract 1. So I have cosine of b equals negative 1. Okay, so it's not over 2, right? So it must be one of our quadrantal angles. So r is always 1, so it must be x that's negative 1. Where on a coordinate plane is x negative 1? Right here. This is the coordinate point, negative 1, 0, right? So where is that? So b would be pi. And that's the only place where x is negative 1, right? Okay. So now I'm going to write my answers in order. What's the smallest? Good. And what's next? Good. And last would be nice. Okay. All right, on number 4, we got cotangent squared minus cotangent squared times cosine squared equals 0. Again, not looking like one of our basic 8. So what do you guys think we should probably do? Factor. But this time I don't have 3 pieces, I only have 2. So this would be like what we did on number 2. So on number 2, what did we do? Right, we took out like a GCF. So what do you guys think we might could do on number 4? All right, so let's do that. Just a cotangent? Cotangent squared, okay. So if I take cotangent squared out of cotangent squared, what would be left? Good. Minus cosine squared, good. Equals 0. All right. And now I've got my factors. All I have to do is take them and set them equal to 0, right? So I'm going to have cotangent squared of x equals 0. And 1 minus cosine squared of x is equal to 0. All right, so for the first one, it's already pretty much solved, right? The only thing I need to do is get rid of the square. How do you get rid of a square? Okay, so I'm going to take the square root. Okay. When I take the square root of something, I have to consider the positive or the negative, right? Because if I asked you what square root of 9 is, you might tell me 3, because 3 squared is 9. But what's negative 3 squared? Also 9, right? So we have to consider that it could have been positive or negative. Now in this case, is there a positive and a negative 0? No. So it is truly just asking what is cotangent of 0. Okay, now cotangent is the reciprocal of tangent. Okay, so this would be x over y because tangent is y over x, right? Okay, so I don't need that part. This is what we're looking at. Am I allowed to have 0 in the bottom of a fraction? So, for us to have gotten 0 instead of undefined, it wasn't the y that was 0. That would have been undefined. It must have been the x. And where did we say that x is 0? Top and bottom. So the top is pi halves, bottom is, okay. So we get pi halves and 3 pi halves as answers from this piece. Okay? All right, now I need to solve that other equation. So what should we do first? Subtract the 1. So I'd have negative cosine squared of x equals negative 1. Then what do we do? Divide by negative 1, right? This is like having a coefficient of negative 1. So then that would leave us with cosine squared equals positive 1, right? And then how did we say we get rid of a square? Take the square root. All right. Now this is what I was talking about where we have to consider plus or minus. Because what is the square root of 1? 1. Okay. Because 1 times 1 does give me 1. But what about negative 1 times negative 1? Would that work as well? Yeah. So we have to consider the positives or negatives anytime we take a square root. All right. So cosine is x over r. Well, r is always 1, right? So I must be trying to think about where x is 1 or negative 1, right? Because we're considering positives or negatives. So where is x 1 or negative 1? Left and right. Okay, over here, what's that value? 2 pi or 0, yeah. Typically we go with the smaller of the two, so we'll go with 0, okay. And we said also over here, pi. Okay. Now, in this particular case, we already talked about this just a second ago. We said y could not be 0, right? Because it would give me undefined. Okay. So at these places, right, if I were to go and substitute that information in, if I were to take cotangent of 0, right, then those aren't going to work over here. So in this particular case, I'm getting rid of these two solutions because they won't work for cotangent. All right. Because we said it did work here, but we said it wouldn't work here because that would be undefined, right? We'd end up with 0 in the bottom of a fraction. So if you want to make a little note, that's why we're saying can't use these because cotangent of 0 and pi are undefined. So it would just be the pi halves and 3 pi halves would be our only answers that we would use. All right. Okay, let's look at number 5. Okay, so for number 5, again, I probably want to move everything over to one side of the equation. But before I move it over, I'm going to end up with different terms, right? I'm going to have 3 things that I want to try and factor, like number 3. Well, that one had both cosines, right? Or on number 1, when I factored, that one had both terms of sine. So I'm not going to be able to factor this one if I've got a cosine and a sine. But we do have some basic 8 identities that might allow us to replace something. Anyone remember what we're allowed to replace sine squared with? Very good. So I'll have 3 cosine of x plus 3 is equal to 2. I'm going to replace that sine squared with 1 minus cosine squared. All right, so before I move everything to one side, I'm going to go ahead and distribute that 2 into this parenthesis. 2 times 1 would just be 2. 2 times negative cosine squared would be negative 2 cosine squared, right? Okay, how would I move a positive 2 to the other side? Subtract it, okay? How would I move a negative 2 cosine squared to the other side? Add it. Okay, so there are no other square terms on the other side, right? No like terms to add it to. So it'll just be 2 cosine squared of x. Then we have that 3 cosine of x that was already there. We had a 3 over there, and then we subtracted a 2, and those are like terms, right? So 3 minus 2 would give us 1. And now that's set equal to 0. So now we can factor it. So I make my factors. Remember, whatever I put here and here comes from this first term. So what multiplies to give us 2 cosine squared? Good. And what multiplies to give us 1? 1 and 1. So we check inside. 1 times cosine is 1 cosine. We check outside. 2 cosine times 1 is 2 cosine. Check that middle term, and we're supposed to add and get what? 3 cosine. So what would I need my signs to be? Right. I need them both to be positives, so we get a total of 3. All right, and then what do I do with my factors? Equal them to 0. So I'll have 2 cosine of x plus 1 equals 0, and cosine of x plus 1 equals 0. All right, so for that first one, first thing we would do is subtract the 1, and then we would, right. So we're going to end up with negative 1/2. And remember, cosine is number of fingers to the left. So what finger do I bend so there's only one to the left? So that would be pi over 3. But it is a negative 1/2, right? So what quadrants is cosine negative in? Right. So I need something that's a multiple of pi thirds in those quadrants. What would that be? Very good. Okay. For that other equation, to solve, all we would need to do is subtract 1, right? So we end up with negative 1. It's not over 2, so it must be one of those ones on a quadrantal angle. R is always 1, so it must be x that's negative 1. Where is x negative 1? Very good. So I'm going to write all my answers. What's the smallest? 2 pi thirds. And then the biggest one is that 4 pi thirds. There we go. All right. Okay, we just got a couple left. All right, on number 6. Okay, for number 6, as it's currently written, not going to be able to factor, even if I moved it all to the same side, not like terms. So maybe we use some of our basic 8 to rewrite. So let's start with cotangent. What am I allowed to rewrite cotangent as that might have a cosine in it? Cosine over sine. So I'm going to change this out for cosine of x over sine of x is equal to that 2 cosine of x. Okay, so I either need to subtract that 2 cosine and move it over, or you also could put this over 1. And because there is an equal sign there, what am I allowed to do? All right. So 1 times cosine of x would just be cosine of x. And then 2 cosine of x times sine would be 2 cosine times sine. And that way we got rid of the fractions before we moved everything over. Okay, so now I can subtract this cosine over. I'd have 2 cosine of x sine of x minus cosine of x equals 0. All right, so I don't have 3 terms, but I do have 2 terms. When it's just 2 terms, we usually look for a GCF. So what do they have in common? All right, so let's take out a cosine of x. I'd be left with 2 sine of x minus 1, all right? And now that I have my factors, how do I solve a factor? Right. Okay, that first one is already solved. So we know r is always 1, so if x equals 0, it must be because the x value was 0, right? So where is x 0? Top and bottom, which we said are and nice. Okay? On that other equation, we got to solve first, right? So I'm going to add 1, and then I'm going to divide by 2. So I end up with 1/2. And remember, sine is number of fingers to the right. So which finger do I bend so that I have 1 finger to the right? So this would be pi over 6. Very good. And I am apparently looking for where it's positive, right? Because that's a positive 1/2. So it is positive in quadrant 1, so pi 6. And then I need a multiple of that where sine is positive again, which is in quadrant 2. 5 pi 6. Very good. So my answers would be, smallest is pi 6, right? Then pi halves, then 5 pi 6, and 3 pi halves. Okay, last one. Okay, if I'm going to add 2 fractions, what do I have to do? Get a common denominator. Okay, so I should multiply my first fraction by 1 plus sign, right, in the top and bottom. What do I multiply that second fraction by? Right. Okay, so in the top of that first fraction, I'll have 1 times 1, which is 1. 1 times sine. Sine times 1. Another sine, so I've got 2 of those, right? And then sine times sine, which is sine squared. Good. And then in that second fraction, so plus, cosine times cosine is cosine squared, right? And they all now have that common denominator of 1 plus sine of x times cosine, right? All right. So right here, I've got sine of x squared plus cosine of x squared. According to our basic 8, what is sine squared plus cosine squared equivalent to? 1. So I can take that out and replace it with 1. So I'd have 1 plus 2 sine of x plus 1 over 1 plus sine of x cosine of x. Any like terms that we could combine up there? 1 and 1, which would give us 2, right? So I'd have 2 plus 2 sine of x over our common denominator 1 plus sine of x cosine of x. Okay? Numerator there. What do you guys think we could maybe take out of that numerator?
2.
A 2. So if I did, I'd be left with 1 plus sine of x, right? Over that common denominator of 1 plus sine of x cosine of x. So what do you guys think? Anything we can cross out? Right. So I'm left with 2 over cosine of x, right? Okay, and don't forget, the other side of the equation said that this was equal to 4, right? So now I have gotten this all the way down to 2 over cosine equals 4, right? Okay, so now how would I get cosine out of the bottom of a fraction? What would I multiply by? Cosine. So I'm going to multiply this side by cosine, so it'll go away, but that means I also have to multiply this side by cosine, right? So now I've got 2 is equal to 4 cosine. All right, so I'm trying to get cosine by itself, right? How do I get rid of that 4? Divide. So I'm left with 1/2 equals cosine. All right, and cosine is number of fingers to the left. Which finger do I bend so there's 1 to the left? So that would be pi thirds. And where else is is cosine positive besides quadrant 1? 4. So what's equivalent to that in quadrant 4? 5 5/3. So that would be our answers. All right, so that's it. That's it for our trig. So starting tomorrow, we're going to begin reviewing. We're going to take our test on Thursday and Friday, so you'll have 2 days of review.